Today, we will answer this geometry challenge coming from one of our followers. And the question goes like this. Given this triangle ABC, now let's draw a segment that is parallel to side AB and a segment that is parallel to side BC and another segment that is parallel to side AC. Now the area of this small triangle is 1 square unit. The area of this quadrilateral is 15 square units. The area of this region is 8 square units, and the area of this shaded region is 3 square units. And the question is, what is the total area of this triangle ABC? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. The area of this triangle ABC is 49 square units, and that is the answer to this question. And of course, the question is, what is the solution to find the answer on this question? So let's begin. In order to answer this question, we will use one theorem, which is the area of similar triangles theorem. So it states that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. We will use this concept because we have a lot of parallel sides. And if we have parallel sides, we create similar triangles. For example, this small triangle having an area of 1 square unit. This is similar to this triangle having an area of 4 square units. This is not hard to prove that these two triangles are similar. Take note, all of these corresponding angles must be the same thing. And also take note, this small triangle is also similar to this triangle having an area of 9 square units. And also, this is similar to this triangle having an area of 16 square units. And of course, this triangle is also similar to the whole triangle, which is a triangle ABC. Now, let's use this concept to answer this question. Now, let's call the base of this small triangle be equal to x. Consider this triangle having an area of 16 square units. These two triangles are similar, and the area of the big triangle is 16. In short, the length of the base of this triangle is 4 times the length of this small triangle. So the base of this big triangle must be equal to 4 times x. Now from here, going back to the small triangle, let's relate this to this triangle having an area of 9 square units. In short, the base of this big triangle must be 3 times the length of this small triangle. If this is x, this length right over here must be equal to 2x. And of course, they add up to 3x. Focus again on this small triangle and to this big triangle right over here having an area of 4 square units. Since the area of this triangle is 4 square units, the length of this base must be twice the length of this small triangle. So if this is x, this length right over here must be equal to x also. In short, they add up to 2x. Now from here, let's focus on this parallelogram on the bottom part. Since this is a parallelogram, the length of its opposite side must be the same. If this is x, the bottom part is also x. And here comes another parallelogram. If this is 2x, the bottom part is also 2x. We can now find the area of the entire triangle ABC. Because take note, this small triangle is similar to the big triangle ABC. And the base is x, and the base of this big triangle is 2x plus 4x plus x, or simply equal to 7x. In short, we can use, again, the area of similar triangles theorem. So we have the area of the small triangle is 1 over the area of the whole triangle ABC equals the base is x of the small, and the base of the larger triangle is 7x raised to the power 2. Simplify, x and x cancel out. This will give us 1 over 7 raised to the power of 2. And 1 over 7 squared, this will give us 1 over 49. Now get the reciprocal, and we get the area of the entire triangle, which is equal to 49 square units. And that is our answer to this question. Therefore, given this figure, then we get that the area of the entire triangle ABC simply equal to 49 square units. Before we end this video, let's have an extra challenge. The goal is to find the area of each parallelogram, namely X, Y, and Z. I will wait your answer in the comment section down below. So see you on our next video. And as always, we're done.